Okay, we continue with our example 8. Now if you look at example 8, again you have the discrete random variable with the following cumulative distribution. So if you notice here, this is capital Fx, so this is representing cumulative distribution function. But if you look at these intervals here, now you have x less than 1 but equals or greater than 0. Even though they are all in intervals, but they are not continuous variables. They are still discrete random variables because x means is just equal 0, x means only just equal 1. In this case here, x equals 2, x equals 3, x equals 4, x equals 5. So please take note, because we are still doing for discrete random variables. That is why we don't have values like x equals 0.5, x equals 1.6, 2.7 and so on. So you are taking only exact values. So we have x 0, 1, 2, 3, 4, 5. And don't forget, we are given the cumulative distribution function. So what you need to do is you need to construct your probability distribution function. So you need to determine your x values here. Alright, so of course we have the x values 0, 1, 2, 3, 4 and 5. And here the lower part here, the lowest column here is referring to your cumulative probabilities. So if you take back, alright, so you're basically substituting all the given values into the final rows here. So you have 1 over 21 when x is 0, 3 over 21 for x is 1, 6 over 21 x is 2 and so on. And of course finally the value should be 1 because this is the cumulative frequency when the final x is 5 here. So if you want to find for the probability distribution function, this is what you are looking for. This is what you want to do actually. So you need to minus from your cumulative frequency. Okay, so how you get this 6 over 21, 5 over 21 here is you need to minus back. So if you have 1, okay, you actually have 1, and then you minus 15 over 21, you get 6 over 21. So you minus this value here, and then you get this. Alright, and then 15 over 10 15 over 21 minus 10 over 21, you get this value here. And then basically you are reversing. It's like you're reversing. So 10 over 21 minus 6 over 21, you get 4 over 21. So you keep on minusing. Okay, 6 minus 3, so you get 3 over 21. Then 3 minus 1, you get 2. So 2 over 21. And finally this is what it is actually. So you still use that 1 over 21 when x is just 0. So in this case you're going reverse way. You're going reverse way from cumulative to get the probability distribution function. From probability distribution function to get cumulative, you need to add the probabilities. From cumulative to the probability, you need to minus the probabilities. So we are doing the reverse way here for example 8. So if you want to draw for your probability distribution function, so you take back all these values here, and it's just a coincidence that these values are increasing. And of course this is our cumulative distribution function. This is our probability distribution function, and of course cumulative distribution function it keeps on increasing because the properties are accumulating. Alright, example 9 here. Number of room bookings being cancelled each day during a period of 50 days. Alright, the results are shown, and X denotes the number of room bookings being cancelled. Right, so you have X and you also have number of days. You want to construct the probability distribution for the X. So your X takes into account 0 until 7. And how you want to get that 0.4 or 0.04 is you take this is total. Alright, the total is 50. So if you take 2 over 50, you get 0.04. Okay, so you get the probabilities for each number of room bookings, right? And then you do accordingly. Okay, you do accordingly for every X values here. Alright, and finally, of course, you come out with this table for your probability distribution X. So meaning that you have to find these values here on your own by finding the probability for each of the X value. So if you plot your probability distribution function in the form of graph, you see that it keeps on increasing and then it goes down. Alright, so again, this refers to the number of bookings. These are your probability values. Now the manager expects that 5 room bookings are cancelled, were cancelled for a day. You want to see whether the expectation was true or not. You need to explain. Now please take note, the expectation here expects that 5 room bookings were cancelled for the day, means that the expected value, or your EX, or in this case your mean, okay, it is expected to be 5. So you want to see whether the expectation is true or not. So what you need to do is to find the exact value for the expected value. So we use back the formula for the expected value, summation of your X multiplied with the probability. So you take back, okay, all the X values multiply with the probabilities here. Okay, we have done this before. And then finally, the exact value is 3.66. Approximately 4 room bookings were cancelled. So is the expectation true or not? So we can conclude that the manager's expectation is not true, since only 4 room bookings are expected to be cancelled for a day, which is opposite to the previous expectation, which was 5. Okay, so this is where you check back using your expected value. You want to find the probability at most 3. The most is 3, so it can take from no room booking, only 1 room bookings, 2 room bookings, and the most is 3. So you need to give all the probabilities for X equals 0, X equals 1, 2, and 3, and you get the total probabilities. And you also need to find the standard deviation for the room booking. So again, come up with a table if you can. Alright, this is the best, so that you can have the values accordingly, and you use the variance here, and of course later on you find the square root of your variance to get your standard deviation. Alright, so please calculate carefully, especially when you're doing for the square and the square root. Alright, so in this case 1.716 is the standard deviation value. Now this is another random variable, that is your continuous random variable. Alright, we are going to look more in chapter 5. Just an introduction for you. It's actually a value that contain in 1 or more intervals. Alright, example here, weight of a person, so it can be 42 or 42.3 kilograms. The time taken to complete a 100-meter dash, or maybe 0.65 minute. Duration of a battery, 67.6%. The height of a building, maybe 100.72 meters. So anything which is you can find in decimals, any values that you can find in decimals or fraction, these are part of your continuous random variable. Okay, please bear with the bad handwriting. Alright, so we're going to look at continuous random variable more in our chapter 5.